Well, thank you all. All right, so it's a pleasure to be with you here in Sacramento. And as David mentioned, our paper on active thermitic material discovered in the World Trade Center dust has just been published earlier this month. And Jeanette McKinley explained how that dust was acquired, at least one of the samples. We report in this paper on 4 separate samples. As I provide a little introduction to this research that we've done on the World Trade Center dust. We all saw these voluminous clouds of dust that were produced as the buildings were destroyed. And so we've looked at and probed very carefully, this team of scientists, 9 of us, looking at the dust to determine what information, and there's a great deal of information actually in the dust that tells us what happened that day. Information about the presence of an explosive or pyrotechnic material that has been ignored in the official reports. In fact, to my dismay, NIST, the National Institute of Standards and Technology, has in fact refused to look for explosive residues in the World Trade Center dust. But we have not. We have proceeded, and I like this quote from Mahatma Gandhi. He said, "When I despair," which I want us to avoid, so I bring this to your attention, "I remember that all through history, the way of truth and love has always won." That's a remarkable fact. "There have been tyrants and murderers, and for a time they seem invincible, but in the end they always fall." Think of it, always. I'm convinced that he's right about that, and that provides a great deal of hope. This is an interesting poll in August of 2006. Federal officials, see here's the poll question. I would like to see how you might answer, even though I may not be able to see all your hands. I certainly cannot. Federal officials either allowed the attacks on the World Trade Center and Pentagon to happen or somehow participated in those events because they wanted the United States to go to war in the Middle East. And how many of you would say that is very or somewhat likely, this statement? Okay, that's a good way. Why don't you applaud if you think this is very or somewhat likely? That's a good way. Okay. Me too. Okay. At that time, nearly 3 years ago, the percentage was 36%, which I thought was already quite high. And I'm confident that if that poll were taken today in the United States, and interestingly outside the United States, you'd find higher numbers even than 1/3 of the population supporting this proposition. So we are making progress. I would like to talk a little bit about the collapse of World Trade Center 7 and the destruction of the towers before getting into our detailed analysis of the material found in the World Trade Center dust. So here we have on the right, lower right, a photograph of the World Trade Center 7 building. It's obscured by dust. We're looking across the World Trade Center 7 plaza. It's interesting. This is in the afternoon, and if you look to just to the right of center, that tall building is World Trade Center 7. And it collapsed about 7 hours after the collapse of the towers. You do not see there a raging inferno of fire because the fires were rather limited from what could be seen external to the building, certainly. And they were random. And yet the building did collapse straight down, pretty much onto its footprint at about 5:20 p.m. in the afternoon on 9/11. Now the World Trade Center 7, here's a more distinct photograph now on the right, had 24 steel beam core columns and 57 perimeter columns. It was solidly built, as you might imagine. And here we will get to see the collapse of World Trade Center 7 on the left, and the collapse of a building, I believe that one is in Oslo, Norway, a known controlled demolition on the right with explosives. Okay, you can see how similar these appear from the videos that we have of the collapse of World Trade Center 7. Notice that it proceeds basically straight down, and we'll talk about the free fall during a period of time for World Trade Center 7 in a minute. It's noteworthy that the 9/11 Commission in their report failed to even mention the collapse of World Trade Center 7. Hence, we see already the need for a new investigation, a thorough investigation that will not ignore the collapse of Building 7. I support Jeanette McKinley and in her support for the New York City CAN referendum, and I've already contributed to that, and I hope that you will do that as well as we seek this new investigation. That's one avenue for an investigation with subpoena power, which is very important in this quest for a fair and open investigation. I'm also encouraged by President Obama as he says there will be more transparency. Let's hope that that is the case as we investigate again the events of 9/11. Now, the FEMA report on the collapse of World Trade Center 7 stated, now their best hypothesis has to do with fire as being the cause of this collapse. They didn't discuss explosives being a possibility, but fire. And they said, our best hypothesis has only a low probability of occurrence. I agree with that. And so we look for other hypotheses. When one doesn't work, you look for other hypotheses. Now, NIST last August came out with a preliminary report, finally, after considerable delay, on the collapse of World Trade Center 7. And they said, quote, failure of a floor beam in fire is a rare event, and indeed there have been many building fires that have not resulted in even local failures of the floor system. They also admitted that there had never been a complete collapse due to fire, which is true. So here's what they stated as their challenge. The challenge was to determine if a fire-induced floor system failure could occur in WTC 7 under an ordinary building contents fire. Now, you see, they're explaining that they're looking for a fire-induced explanation for collapse of the building. Which already seems to have the blinders on. We keep hoping and encouraging them to look for residues of explosives. So, how did they proceed? Well, first of all, they did not test any of the steel in World Trade Center 7 to look for the effects that they could learn from actual hard physical evidence on the steel. Instead, they proceeded with computer modeling with parameters. These are adjustable inputs into the computer model. So basically, it's a black box. And one of the parameters or assumptions that they plugged in to their computer model was this. The steel was assumed in the FDS model to be thermally thin. Thus, no thermal conductivity was used. Now, let me try to explain what they're talking about here. Let me go to this. No thermal conductivity was used. I happen to have with me here I brought along a rusty nail. It's kind of funny, I suppose, but there's reasons we'll get to later. If I started to heat this with a flame, it would slowly, the heat would slowly conduct across the metal, even though iron and steel are not very superconductors, they're very good conductors, but they do conduct heat. It's certainly not zero. And I would feel that heat after a short time. Maybe you've done that with a pin or a needle. As I've worked on slivers, I've had to heat up a needle with flame, and that heat transfers along the needle, stainless steel, for example, to my fingers quite quickly in just a few seconds. Well, what they did is they turned off the thermal conductivity. Now, nature won't let you do this, even if you are a national federal laboratory, under, incidentally, the Department of Commerce, I should point out. Okay. Now, secondly, another parameter that is an observation in their model, even after turning off the heat transport, and burning office materials near this critical column, column 79, they said in their report. It appeared likely the critical damage state, in other words, the failure of this column, occurred between 3.5 and 4 hours. Now, burning office materials, we're talking about chairs, papers, carpet, desks. Some of you have made a fire, a bonfire. Does it last 3.5 to 4 hours with immense heat? No, actually, from our experience. And NIST, interestingly, had previously published data on heat release during the burning of office materials. This is in one of their earlier reports. And you can see from the plot, there's two. The red is the FDS model. The black is experimental data. They don't line up exactly, but the point is that by 2,000 seconds, the fire is way down compared to what you had at about 600 seconds. 600 seconds is 1/6. It's about 10 minutes into the fire. So you see that by the time you get to 40 minutes, towards the end of the plot, then the heat is diminishing, just as you would expect if you built a campfire or even a bonfire. The fuel burns up rather rapidly, and you don't have anyone in the building continuing to push office materials towards this critical column to keep this fire going for 3.5 to 4 hours. Nevertheless, that is what they somehow assumed, that there would be this intense heat for that period of time. Again, the critical damage state occurred between 3.5 to 4 hours. Now, you can't just let the office material fires continue to burn when the experimental data shows that the heat diminishes rapidly after about 15 to 30 minutes. Secondly, you can't turn off the heat transport. In other words, the heat being conducted away from the critical column because there are connecting members connecting to these columns so that the heat is transported away. The conductivity is not zero. Now, in a computer model, you can do any crazy thing you want, but nature won't let you do this. And some of us feel very strongly that NIST should allow us to actually have their model so that we can test it and put in realistic parameters, predicting, of course, that if we do that, the building will not fail. Clearly, if it requires 3.5 hours of heating with no thermal conductivity, then when you put in some conductivity and reasonable values for the length of time for fires, then you'll get much different results. There are some points I would like to mention in the NIST report that corrects old erroneous notions. For instance, Popular Mechanics, full of erroneous notions, I must say, in their 2005 report, stated investigators believe the fire was fed by tanks of diesel fuel. And in the August 2008 report, this notion is thrown out, quoting NIST now, fuel oil fires did not play a role in the collapse of WTC-7. So that bad hypothesis is thrown out, and I hope it gets corrected with the public. That's one of the reasons for these talks, is to correct these erroneous ideas. Again, we would like to challenge NIST to let us have our hands on the model that they used. A theory or a model which cannot be tested by other scientists independently is not good science, because the heart of science is independent checking and verification. So we actually request and politely demand that we as citizens be allowed to use this model, which was, after all, developed with our taxpayer money. Now, in August, again, August 26th of 2008, physicist David Chandler and I both challenged NIST on their preliminary report, World Trade Center 7. For example, In the report, they said that they used a constant speed estimate in estimating the time for the fall of the World Trade Center 7. I pointed out this is not good physics. They also ignored an observed period of free fall, as David Chandler pointed out. So here's what David Chandler noticed. Now these are the dots are data points actually taken from videos of the fall of World Trade Center 7. And fitting a straight line over this portion, as you can see, fits the data points very well for a period of about 2¼ seconds. The acceleration works out to about 9.885 meters per second squared. That's probably more accuracy than you can get from those data. But still, the acceleration due to gravity is 9.81 meters per second squared. This is almost precisely the acceleration due to gravity. And we both, David and I, challenged NIST. This is a public meeting that is over the internet. It's kind of interesting. We sent in questions to NIST saying, look, your report, your preliminary report, has some big flaws and oversights and apparent errors. Can you look into this? And they did look into it, and here's what NIST came up with. Now, if you can remember that a little bit, that fit to the data. NIST, red data points, red circled data points. And again, looking at the actual videos of the collapse of World Trade Center 7, they did a fit, which is the red line, and indeed for a period of 2.25 seconds, just as observed by physicist David Chandler, NIST checked, and sure enough, there is free fall. Nothing in the way for over 2 seconds in the fall of World Trade Center 7. Now let's read what NIST says about this. This is their final report now. Not in the preliminary report, but in their final report. I believe it was November of 2008, last year. And here's what they say. Quote, the slope of the velocity curve is approximately constant between 1.75 and 4.0 seconds. That's a time period of 2.25 seconds. A good straight line fit to the points in this range allowed open circles in the figure we just saw, allowed estimation of a constant downward acceleration during this time interval. Quoting NIST, this acceleration was 32.2 feet per second squared, 9.81 meters per second squared, equivalent to the acceleration of gravity g. Exactly, within experimental errors, the acceleration of gravity g. And then they go on. This free fall drop continued for approximately 8 stories, or 32 meters, 105 feet. So for over 100 feet, the building, as you look at the roof in both cases, is freely falling, nothing in the way. Now in the question and answer period, when David Chandler and I challenged NIST, are there errors looking at the drop of the building? Shyam Sundar said, well, free fall would mean that there's nothing in the way, and that can't happen because as the building collapses, there's a lot of material in the way. I'm paraphrasing. That's basically what he said, and we agreed with that. But now, from the data, NIST is constrained to admit that there was free fall drop for a time period of 2¼ seconds, which doesn't sound like much, but when things are dropping over 100 feet at free fall, that is significant. So this demonstrates, this free fall drop, that there was nothing in the way. No beams, no structure, no concrete floors, no significant mass. Now, how do you get mass out of the way? Explosives. Is there any other way? They didn't answer. In a model in which you have the floors still there because you didn't use explosives, so the floors are intact, as the upper structure hits the floors below, the stationary floors, it slows down the structure. It's just like when you hit, this does happen to us occasionally, you hit something in the way of your car, perhaps a smaller car. It doesn't matter how small it is, it slows you down some. That's conservation of momentum. In order for there to be free fall, which means nothing slowing you down, That means there's nothing significant in the way. And they did not explain, they don't answer how this could happen, unfortunately. Now, I thought they would, after we caught them on their error, they admitted, they checked the data. Yes, there is free fall. It's amazing. You'd think they would change their conclusions. Instead, they simply assert without proof that this period of free fall for over 100 feet, followed by about 1.5 seconds of impeded fall, is consistent. That's their word. Consistent with their results of global collapse, as they discuss in Chapter 12 of their report. But they, in other words, they didn't change anything in Chapter 12 of their report. They just said, oh, yeah, free fall, yeah, sure, that's consistent. Now, you know, a black box computer model, which no outsiders are allowed to test so far, hoping to get around that with, for instance, NYC-CAN, that commission should be able, hopefully, to get a release of this model. Do you think we're satisfied just to sit back and say, oh, well, sure, it's consistent, whatever you say, NIST. After all, you're a federally funded laboratory. We will believe whatever you tell us. We're not satisfied as scientists. I'm embarrassed, frankly, that NIST makes this assertion without proof. It is good that they at least admitted that there was free fall. I want to correct another misleading, it's almost lore now, folklore, because Popular Mechanics in 2005 quoted NIST leading researcher Shyam Sundar. Here's what they said. Quote, this, remember, 2005, on about a third of the face to the center and to the bottom, approximately 10 stories, about 25% of the depth of the building was scooped out. And that was alleged to have significantly weakened the building for its eventual fall. I pointed out, and others have as well, that if this were true, it would lead to an asymmetrical collapse, a collapse toward the face that had been scooped out, which was not observed. But here's the retraction now. In their 2008 report, they say plainly, other than initiating the fires in World Trade Center 7, the damage from the debris from World Trade Center 1 had little effect on initiating the collapse of World Trade Center 7. This is the closest tower, just across the street. And they said it had little effect. It was not fatal to the building. And of course, we agree with that. But then they are left with the only explanation being fires, office materials burning for 3.5 to 4 hours, which is unphysical. That's what we say in science, with the heat transport, the heat conductivity turned to 0. That's also unphysical. No, to the NIST report. We need to get our hands on it and do some real science. Now, I had previously challenged NIST in my paper, which came out in 2005, why indeed did the World Trade Center buildings completely collapse. I challenged them to consider the evidence for a thermate attack on World Trade Center 7 steel. I noted this, which has been published. It was in the FEMA report, Appendix C. It was subsequently published in a scientific journal. New York Times said perhaps the deepest mystery uncovered in the investigation. And this is the evidence of severe high-temperature corrosion attack on the steel, including oxidation and sulfidation. And some of this steel, this Worcester Polytechnical Institute, they said came from Building 7, some from the towers. NIST, however, did not examine any steel from World Trade Center 7 in their report, trying to explain the complete and rapid collapse of World Trade Center 7. They admit they didn't even look for it. Again, I'm embarrassed for NIST to not look at these data, which had been published in a regular scientific journal. They just ignored the data. Now let's look at the towers. I know you're anxious to look at the World Trade Center dust, me too, but there's some things I want to point out about the towers. Solidly constructed. If you look at the photo on the left, you see the core. There are 47 steel core columns, huge columns, as you see in the photo on the right, showing the steel columns there. In addition, there are 240 perimeter steel perimeter beams. I put this stove there with a fire. You know, I have a wood-burning stove. It's made out of steel. I'm just not worried about that thing melting or failing. You know, I mean, and what are they burning here? Oh, sure. Kerosene, which I have a kerosene stove too, and it's steel. I'm not worried about it failing. And office materials, kerosene from the jet fuel, which NIST says burned up within about 10 or 15 minutes, and I agree. And so how do you get this steel to fail? Notice the buildings were not hollow, and there's this, again, this huge heat sink. This is the transport of heat wherever you, so yeah, let's say you pile up this office material next to these columns in the core, which is a good trick to do, and I'm sure the people were thinking about other things. But if you did pile up all this office material, desks and chairs and papers, and you set a bonfire there, do you think that steel would just give up? No, it doesn't. And now, so here's how the official model has proceeded. Besant and Grainger and others in 2007 show this picture. I'm taking it from their published paper, this figure, with the upper block of floors. So the plane comes in, creates a damage, and this upper block of floors, they say, acts as essentially an intact tamper to drive down the rest of the building. Now, I challenged one of the authors with regard to this on Newton's third law, which says that when there are two bodies interacting, so the upper block and the rest of the building below, when a force is applied to the lower block, that is the 85 or something floors below, you see, depending on where the plane went in, an equal and opposite force is applied to the block above. He denied it, but I said, look, you just don't understand Newton's third law. Finally, he conceded, but it's just amazing to me that they would publish this paper without showing the upward force on the upper block. Now, let's look, though. Let's look at the data, actually. So here we see, apologies to Jeanette, they're showing this tower. She doesn't like to see the actual destruction of the towers. There were people inside, and I am also sensitive to that. But now, look, do the upper floors remain, this is the North Tower in this case, remain as a block? Let's look at it again. Okay, here. Now look, that upper block, you see where there's this transition, where the smoke is there? That's about the 95th floor, 94th floor. Well, you see it's the upper block that's being destroyed. Can you see that? And then there's so much dust you can't see much. But clearly it's the upper block being destroyed, as you'd expect, because the upper block has thinner steel and it's been heated so it's weaker. The forces on the upper block and the lower portion of the building, those forces are equal. And so we expect the upper block to be destroyed as observed. But of course, there could be something else going on too, namely the use of explosives. But clearly, the upper floors are not seen to remain as an intact tamper. Rather, they're seen to be destroyed early on in the demise, the destruction of this building. Now, let's look at a photo. Here's a tower. You see the zone of destruction. I just will have to call your attention to the photo on the right. You see where the cloud, it's like a skirt around the building where the dust is billowing out and down. You can tell pretty clearly where the zone of destruction is taking place. But where is the intact tamper, as required by the so-called official model of Besant and so on? I don't see it. And furthermore, there seems to be dust coming upward, which would be quite impossible if the tamper were intact. Now, I ask you, and you can judge for yourselves, does this look more like a tamper, you know, a piston driving down the rest of the building, or does it look more like explosives? There's still more data. So, you know, when you look at the evidence, you say, well, where do they get this idea of a block acting like a tamper? I don't see it. It's not there. excuse me, can we look at real data for a while? It's like getting this to finally look at the period of free fall in the collapse of World Trade Center 7. Now, this report looks at the Deutsche Bank, some 600 feet away from the World Trade Center buildings. And we see this report that nearly 300 more human bone fragments recovered from the roof of this Deutsche Bank skyscraper. That was badly damaged, as you can see from the photo, 600 feet away. So this steel beams, and I'm sorry to say, excuse me, Jeanette, plug your ears, fragmented human bones hurled 600 feet horizontally from these towers during their destruction. Now I ask you if a tamper or pancaking floors would tend to trap bones, or what hurls these bones 600 feet away? I suggest that explosives would do this, and I can't find any other reasonable answer. Certainly not pancaking floors, as popular mechanics popularized, or a tamper, as Besant proposed and published. When we get to a photo on the left, after then both towers are down, you see some perimeter columns still standing in both cases, but look, the core columns gone. I don't see any core columns remaining, and I certainly don't see any stacked up floors, as you see on the right, which was a case of actual pancaking of floors due to an earthquake in the, let's see, where was that? In the Far East. So again, explosives are implied. Now, as I started talking about these questions, these issues, I started discussing these matters actually in September 2005. I presented a colloquium, much as we're doing here tonight, but this was before a group comprised of mostly professors at Brigham Young University. It was the first peer review in that setting. It's often done in science that you give a colloquium to have this immediate review by peers. So I invited professors from across the campus. I did not invite students to this. And there were, I think, around 70 people, 75, at this meeting. And I will say that at the end of that, I asked the question, I didn't say, now, how many of you believe that 9/11 was other than the official story, you know, collapse primarily due to damage and fire, but could have been explosives or something else. I didn't ask that. I asked, is this worth investigating? Do you think there's enough science here to make this worth investigating? I had all but one of, nobody disagreed except for one professor, and the next day he caught me on campus and he said, you know, I've thought about this and I've changed my mind. I support an investigation of these events of 9/11. Now, about this same time, as soon as the paper came out, in fact, online, which was in, well, it'd be early November, I believe, of 2005. This paper was published formally in September 2006, and also, well, in two places. Okay. I don't want to make this too complicated. It is published in the Journal of 9/11 Studies with the permission of authors David Griffin and Professor Scott from UC Berkeley. Now, that paper was published in a separate volume as well, so they allowed dual publication, and the formal publication came out in August of 2006, followed by this publication in September in the Journal of 9/11 Studies. Okay, and of course the paper had been thoroughly peer-reviewed, including the session that I spent with BYU professors before the paper went out to the public. So I had requested peer review. And by the way, I had a lot of emails after that. It was a 2-hour session, you know, hammering over these data that we had at the time. Now, the topic of this slide there was a fellow who called himself a contractor, and that he said he had claimed contacts with Homeland Security. I suppose this is actually true from various things he said. But he wrote to me and to administrators at my university. He said, quote, "The publication of this article can be stopped, and I have the contacts to make this happen. You need to give this very serious consideration. This is an issue that is more important than any individual career." I'm pretty sure the threat here was to my career. He said, "I have learned to appreciate the value of silence, even in the case of superior data and information." Because you see, I responded to his questions and showed him that the data did not support the official story, the official narrative of 9/11. And so he said, "That doesn't matter. Even if the data is superior, I have learned to appreciate the value of silence." Quoting him again, "As painful as it may seem now, perhaps it may be less painful than could occur after publication." The paper came out formally then in August 2006. Approximately 2 weeks later, I was put on administrative leave with very little explanation and offered then, shortly after that, early retirement. And a student wrote to this fellow, found his name. I gave him his name. He found his email. He actually visited with him and then exchanged some emails. This fellow claims that he was responsible for my being pushed into early retirement. And he claims, he said, I should get that and quote that too. It's quite interesting. Sometime I'll have to write a book, I guess. But he said, "You know, the truth doesn't matter," he said. "What matters is that we don't want to upset the apple cart." And I'm paraphrasing, but he said, "You know, the truth is not important." And, you know, to me, that is not the case. I remind you again of the quote from Mahatma Gandhi: "Truth and love will cut their own way and will finally win." Okay, thank you. Now, a lot of the material that we've just discussed, but not all of it, but a lot of it is published in the Open Civil Engineering Journal, April, so just 1 year ago this month. And you can find the link to this if you go to Journal of 9/11 Studies. Our more recent papers, there's 2 recent papers by our team, you can find at this same journal. The second paper in the Environmentalist was actually by Kevin Ryan and James Gorley and myself. So just 3 members of the team. Okay, so I suggest you go there. Now from this paper, I have this interesting admission from NIST. I'm quoting from the paper. I hope you'll take time to read it. We put a lot of work into these papers that are published formally after peer review in scientific journals. Here's what NIST wrote to us. "This letter is in response to your April 12, 2007 request for correction." See, we pointed out they made a number of errors. We requested. It's a formal procedure, request for correction. NIST replies, "We are unable to provide a full explanation of the total collapse." Now that may be a bit of a surprise after 10,000 pages that NIST put out. It may also be of interest to Congress, which commissioned NIST to find a full explanation for the demise of the towers and World Trade Center 7. I just wanted to point out that they have admitted that they are unable to provide a full explanation. You know, if they would just look for explosives, you know, maybe they would get that that elusive, explanation of the total failure of these buildings and their demise. This is quoting from the NIST letter, and just to show you that I'm not making this up. Okay, this is our second major paper. I mentioned environmental anomalies at the World Trade Center, evidence for energetic materials, in other words, explosives. Formally published, solid journal, and of course peer-reviewed before publication. Now, NIST stated, NIST has found no evidence of a blast or controlled demolition event. Did they look? They admit they did not. So, you know, it's remarkable to make a statement like that. And I've been pointing this out in talks. It's in the paper. Let me make it bigger for you so you can read it. A reporter, and I hope that we have some investigative reporter types here tonight. Jennifer Abel, bless her heart, Hartford advocate. After a talk I gave in Hartford in 2007, I think it was, she called up the spokesman, Newman, at NIST. And she said, what about that letter where NIST said it did not look for explosives? The NIST spokesman replied, right, because there was no evidence of that, of explosives. Oh, but she didn't give up. See, this is good. But how can you know there's no evidence if you don't look for it first? Newman, if you're looking for something that isn't there, you're wasting your time. Now, how do you know it's not there if you don't look? It's a bit of a circular argument, of course, and it's most unfortunate that they didn't look for explosives because they are there. I don't know if, I guess I will mention this as another topic. I think we have to be careful in this 9/11 truth community, which I am a part of and which I congratulate its growth, as evidenced by the growth of architects and engineers for 9/11 truths. Over 3,000 members and over 400 at my last check, architects and engineers among that group. 600 now? Wow, over 600 professional, I understand, architects and engineers then have signed up with this group, demanding a real investigation of 9/11. Anyway, there are some that cry wolf, and they show this photo, and I want to show it to you. If you look at this photo, you see what looks to be a mushroom cloud extending upward from the collapse of the South Tower. It looks like a mushroom cloud. They use the term blasting to the stratosphere, and they claim that this is evidence for a mini nuke, a small nuclear bomb in the tower. Now, I've written a reply to this. You see, it's okay to come up with a hypothesis, but please present the data fairly. And so here's what we look at now from a side view, viewed from the west. The same event, the collapse of the South Tower. But what you see is that this so-called mushroom cloud, as it appears when you look from a certain angle at the South Tower, it looks like there's a mushroom cloud. In fact, that cloud is just the plume. Viewed from the west, it's the plume from the North Tower fires that is passing over the South Tower. You see, this plume is passing over, so when you look from here, it looks like a mushroom cloud. It is not evidence of a mini nuke at all. And there is other evidence that goes against the mini nuke. For instance, the lack of iodine-131 in samples tested about a month after 9/11, 2001. I go through that in Journal of 9/11 Studies if you wish. It's okay to raise a hypothesis, but please look at the data fairly and don't send us on wild goose chases, crying wolf. People will get upset. For more information, you can look at the Journal of 9/11 Studies and, of course, the papers published in the more established journals. I've urged authors and serious researchers to publish in established journals. Upper left is Professor David Griscom, a physicist and a fellow with the American Physical Society, who read our paper, by the way, and this is the red gray chips paper, which is next, or almost next, and supported it, and he's also published then a paper challenging the official story of 9/11 in the Journal of 9/11 Studies. Okay, other authors. Now the dust. Finally we get there. The 9/11 dust, we've seen these voluminous clouds produced as these buildings were destroyed. I only use the term collapse for Building 7. I don't think it applies to the towers. They were destroyed. as we have discussed this evening. But the dust formed during the destruction was studied very quickly and found to be extremely dangerous. For instance, Greg Swayze, U.S. Geological Survey, says, quote, tests revealed the dust to be extremely alkaline, with a pH of 12.1 out of 14. Some of it was as caustic as liquid drain cleaner. You can see why Jeanette needed to cover her head and face with a wet towel in order to get away from this terrible cloud of dust as she left her apartment. It was obvious, he says, that precautions had to be taken to protect the workers and people returning to their homes from the dust. These results were sent to the EPA. It was reported in 2006, April, so 3 years ago. The number of people with medical problems linked to the 9/11 attacks has risen to at least 15,000. The coroner said the death of a policeman who developed a respiratory disease was directly linked to 9/11. Now, one of the problems has been identifying and being sure that it was the dust that caused these coronary problems as opposed to some other condition. But we have found something in the dust which will help nail this as being World Trade Center dust, as I'll show you in a minute, these red-gray chips. So this is a serious problem. Now, do you think surely our government would not lie to us? We all know about the weapons of mass destruction in Iraq, for example. Sorry, it's not a laughing matter. Okay. There's a report that came out in 2003, actually. What happened was, let's look at the middle paragraph. EPA Inspector General Nikki Tinsley did some checking. How is it that the EPA, here's what she found. The EPA issued press releases saying the dust was not particularly dangerous. She says, middle paragraph, the White House convinced EPA to add reassuring comments regarding the dust and delete cautionary ones. The National Security Council controlled EPA communications. So this is who we trace this to. The first paragraph, at the White House's direction, the EPA gave New Yorkers misleading assurances that there was no health risk from the debris-laden air after the World Trade Center collapse, according to an internal inquiry. Bottom paragraph, the EPA issued 5 news releases within 10 days of the attacks and 4 more by the end of 2001, all reassuring the public about air quality. But soon, respiratory ailments and other problems began to surface in hundreds, and as the previous report said, now the number is something like 15,000 who are affected. This, I think, is serious to lie about. I use the term lie. In science, we call it data falsification. Doesn't sound as bad. But when it hurts and kills people, it is very bad, as you know. There's some more we could read about this. Let me go on here. I like this statement at the bottom. I want an independent investigation to determine exactly who at the White House manipulated the information. The White House did not respond to requests for comment. This is a big issue. Now we get then to our paper, where we look at the dust and we're looking for explosive residues and materials in the dust. In the paper, we discuss 4 independently collected dust samples. One was collected within about 10 minutes after the collapse of the second tower, the North Tower. And the locations of the collections are shown in the blue circles. The orange-red circles here show the locations of the towers. And Jeanette McKinley's, the interior of her apartment is shown in this photograph, and her apartment was just across from the South Tower. And as she described, the windows broke as the South Tower collapsed. The windows of her apartment broke inward and the dust flowed into her apartment. And then she provided me with a dust sample in the presence of witnesses, so that, and with photos, so there's a well-established chain of custody. She has since then provided dust samples to other scientists directly, without going through me or without me having any part of that. I mean, except to encourage other scientists to look, you see, to seek these samples. These are some views of the World Trade Center dust. We see these remarkable red-gray chips, upper right, we'll talk about those some more, and remarkable spheres in abundance in the dust. Many of these are rich in iron and aluminum and silicon together, a very unusual combination, which is not from melting of steel in the towers, because of the aluminum and silicon present in significant amounts in many of these droplets. And the molten the previously molten nature of these droplets is shown by the fact that they have formed into spheres. When you blast water in the air, it forms into spheres by surface tension. Liquid metals will do that as well. They form into spheres and then cool, and you find all these spheres just in very large quantities then in the World Trade Center dust. Now, here are some close-up photos through microscopes of the World Trade Center through a microscope of the red-gray chips. Can you see in the right-hand photo, you see the red side, and then the insert shows one of these red-gray chips turned on its side, so you can see red on one side and this shiny black-gray surface on the other. Very characteristic, very interesting. We find it in all the samples that we have examined so far of the World Trade Center dust, which is 6 samples by Dr. Pfeiffer and myself. 4 of these are reported on in this article. We keep looking at more samples. Others have observed these red-gray chips as well. This photo was taken by Mark Basil, a scientist in New Hampshire area, and he had a sample sent directly to him, I know, of the World Trade Center dust. Also observed in France by Dr. Frédéric Henri Coignier. And you can see very clearly in this photomicrograph by Mark Basil, the red and the gray layers. Very distinctive, very unusual and striking. Now, this is the electron microscope and XEDS system used at Brigham Young University. Dr. Pfeiffer is the lab director, TEM lab director. He does excellent science and checked and rechecked the data that went into this paper. Most of the photomicrographs and XEDS, well, certainly I took a lot of the photomicrographs through the optical microscope. He did most of the electron microscope, the SEM and BSE images that you'll find in the with this machine, that you'll find in this published paper. Okay, here's the paper as it appears now online. It is an open journal. We selected a journal that would allow us to publish a lot of data. There are something like 33 figures, 30, I can't remember exactly, 33 figures, color, 25 pages. That's a long paper. And this journal was willing to work with us. It took a long time, a very tedious peer review process, many pages of peer review on the initial submission, followed by this paper. This is a photo of Niels Harrit, who became the first author, long story there, and great fellow, associate professor at the University of Copenhagen in Denmark. He's been speaking out in Europe, for instance, Denmark and Paris. I know he's spoken out on these results and on 9/11 in general. Of course, he's very skeptical of the official story of 9/11 and agrees with the conclusions of this paper, which are that these red-gray chips, the red material in these chips is explosive or pyrotechnic material and should not have been in the buildings. That's his statement is, this material should not be in a commercial office building, certainly not in these quantities, as we'll see, some 9+ tons of this red material in the World Trade Center dust, extrapolating and estimating, but that's a lot of material from what we've observed. I'll go through those numbers in a minute. We see these chips, the same characteristics as we'll see in all 4 samples. So we do a check, a consistency check between the various collectors, and we see the same signature in all 4 samples. This is now proceeding to a higher magnification. This previous was an optical microscope. Proceeding to higher magnification in an electron microscope. We see the red layer here on top and the gray layer below. Proceeding to still higher magnification. I guess we'll have to wait. Okay, at this magnification we can already look at and sample the red and gray layers to get an overview of the chemicals present. We use X-ray energy dispersive spectroscopy. That will be on the quiz. Please make note of it. And at first we look here at the gray layers, which show oxygen and iron very clearly, a small carbon peak. And the question arose, I had this question early on compared to now. Perhaps what we're seeing is rust in the gray side, and the other is, the red is just paint, you know, so we're going to check that hypothesis. We check very clearly. Looking at the red layers, however, there is no zinc, no manganese seen either. The composition, the nominal composition of A36 steel, as used in the World Trade Center towers, has about, you see, 0.8 to 1.2% manganese. So where's the manganese? You look at that bottom plot, for example. These are the 4 samples showing the same, essentially the same chemical signature. The principal elements are the same. Anyway, no manganese and no zinc. It's starting to not look like steel from the buildings because of the lack of manganese, and not like paint either, not like primer paint, as we'll see, because of the lack of zinc. Notice the elements that are there. Carbon, significant peak. Oxygen, aluminum, silicon, and iron. Okay. The one peak, number 3, has a small amount of calcium, potassium, and sulfur, but that could be some contamination. Dr. Fair was very careful to break these, if you can imagine these small chips, that he broke a piece and then looked at that fresh surface. There's so much calcium sulfate in the dust that you can still quite often see calcium and sulfur showing up just for that reason, because of the wallboard. Okay, now here's paint, the primer paint used by Tenemec, supplied by Tenemec for the World Trade Center. We see that in the pigment, this is from Appendix D of the NIST report. You know, we get facts from NIST, and they simply report the pigment and the components in the primer paint, which is high in zinc, magnesium, aluminates, calcium, and so on. But the absence of zinc, again, shows that this is not the primer paint. Even Frank Greening admitted that, if you know Frank. Thank you, Frank. The zinc is not there. Let's go back. Zinc is not there. And others have said, well, maybe this is somehow, you know, as the buildings fall, you just get a mix of, I don't know, aluminum and zinc mixes up, and you get this wonderful red stuff. Sorry, where's the manganese, first of all, and where's the other junk that we find in the dust, which is zinc and chromium and calcium and so on in abundance. But you see, those are not seen in abundance. There's a little apparent contamination in 3, but the characteristic signature does not show any zinc or manganese. Okay. Mark Basile, I mentioned he's looking at this independently, has confirmed these principal ingredients. Now, he did not clean his surface, and so you see some surface contamination. Notice the calcium, titanium, copper, again, all this stuff in the buildings. That's what you'd expect if this is just somehow a agglomeration of building materials. But when you clean the surface, as Dr. Ferrer did, then you do not see chromium or titanium or zinc. No zinc. It's not paint. Certainly not the Tenemec primer paint used on the steel. This one we tried to rotate the plot, but were unable to. Beautiful photograph by Professor Henri Coignier in Marseille, France, using again electron microscopy methods. And his XEDS again shows iron, aluminum, silicon. He didn't clean the surface, so notice, can you read that? Contamination variable en calcium and sulfur. As you expect, calcium sulfate is the principal component of wallboard. But notice again, well, it's a little hard to read. I'll spell it out then. The principal ingredients here in the red material, spectre du rouge, de la couche rouge, okay, the red side, carbon, oxygen, aluminum, silicon, and iron, just as we observed. So these results confirm our published results. And I know that Mark is preparing his paper for publication in a established scientific journal. And I hope Dr. Henri Coignier will do the same. Now, as you read in our paper, which I hope you will read, let me ask for applause. How many have actually read at least part of this paper? Okay, that's good, but it's obviously not all. So I'd encourage you to read it. It's not hard to find. If you Google, for instance, Harrit, Open Chemical Physics Journal, I should pull it right up for you. Red gray chips is a good way to Google for this too. So I soaked some chips in paint solvent working with Dr. Ferrer. We found, this is one of the early tests we did, the chip does not dissolve. Now, paint, which we also soaked in, I bought the solvent, it's methyl ethyl ketone, purchased it at a hardware store, it's a paint solvent. So I put chips of paint in there and they dissolved. Certainly the paint got flimsy and then you see dissolving, dissolution. But these chips did not dissolve at all. And there's no zinc, and now this, it's just not paint. Instead, what you see in these photographs is that the red portion swelled. The gray-black portion did not seem to be affected by the solvent at all. The red portion swelled, and can you see in the right photo the porosity that's now evident in the chip, the red material? And perhaps you can notice that there's some red material, and then with pores, this is primarily silicon dioxide, silica, with some iron oxide mixed in. And then in the left-hand side of this photo, the right photo, you see a silvery region. We found that the aluminum, elemental aluminum, separated out under the action of this paint solvent. Very interesting. Remember, there's a lot of carbon in here. The carbon does seem to break down. Okay, let's look at the data. Getting ahead of myself. This is in the paper. After the MEK soak, we now see regions where we see aluminum separated from silicon and oxygen. So if you look at the leftmost plot, you see a region, you see the silicon and oxygen a little bit of iron, essentially no aluminum. This is not aluminum silicate. It's not kaolinite, as some debunkers said. Oh, it's kaolinite, that's all it is. No, you can't use a paint solvent and separate the aluminum from the silicon oxide in an aluminosilicate. It's just a solvent. It's not a reducing agent, okay? So, and now if you look at the middle plot, you see a large peak of aluminum, very little silicon. Again, this is not an aluminosilicate because the aluminum has now increased dramatically, just has been pulled out of this matrix of stuff in the red material. The oxygen is much less than the aluminum, and we deduced, Dr. Fair is an expert in this machine, that the aluminum content exceeds the oxygen content significantly, and so there must be at least some elemental aluminum, which is one of the prime ingredients of thermite. There is also iron oxide, as shown in the rightmost plot, oxygen and iron. Here, the oxygen in each case was sufficient to completely oxidize the iron, unlike the aluminum, where the oxygen was insufficient to oxidize all of the aluminum. See the difference? So elemental aluminum had to be present. Some of it, at least, was element. You know, you have little bits of aluminum, little particles of aluminum. You get an oxide layer that forms very rapidly. It's called passivation, and that occurs on the surface and actually protects the interior aluminum from being further oxidized. Sorry, science. To me, this is exciting. You look at that and you say, whoa, whoa, there's aluminum in there, elemental aluminum. It's not aluminosilicate because the silicon's separate, and there's iron oxide. Not, you know, yes. Thank you for that emphasis. And this is not just elemental iron. We didn't find any evidence of that in the red material. So now we go on to higher magnification, 50,000 power. It's Dr. Fair pushed it up, and this, he was the first to see this. I'm just getting goosebumps here again. I mean, I just, you see these grains. Can you see the extreme right there, the bright spots, and you see them more in the, like the center of the SEM image as well. These are grains, and they happen to be rich in iron and oxygen. And the aluminum is found in these plates. Can you see right near the center below that set of grains, there's aluminum. And then around this, there's this kind of a wavy material. This is an organic matrix rich in carbon. Now this red material is most interesting to us because it has aluminum inside these plate-like structures. The plate-like structures are quite uniform in thickness from what we can observe with the scanning electron microscope, 50 nanometers wide. Plus the iron oxide appears in these ultrafine faceted grains, approximately 100 nanometers across, and again, very uniform. Again, let me emphasize, this is not from the building collapsing with, sure, there's aluminum and iron and titanium and calcium and sulfur and zinc and copper in the building. But that's not what you see here. Here you see uniform, right? Grains. This is engineered material. I just, you know, if you're a scientist, you just can't say, well, randomly, you know, the building falls down and we're going to get a few of these things. No. And we get 9 tons of this stuff as we extrapolate. So there's not building stuff randomly mixed together. But what can it be? Okay, now we'll discuss the thermitic reaction, which involves aluminum, elemental aluminum, and iron oxide, which are present in the red material. When these are ignited, as I show in this little demonstration experiment that I did, aluminum powder and iron oxide powder, you get aluminum oxide. Can you see the white plume wisping away above the molten iron? The molten iron is a yellow-white hot coming out of this reaction. It's extremely hot, and you get molten iron. You notice you start out with iron oxide, but you end up with iron. What happened? You start out with aluminum and end up with aluminum oxide. Can you see what's happening? The aluminum grabs the oxygen from the iron oxide, and you get the end products, aluminum oxide, much of which comes off in this plume. It looks like smoke, except it's white. It's quite bright, and it floats away, fine white plume. And the molten iron then form, reduced iron. We'll see, but I want to just say now, while we're thinking about it, that this red material, when we ignite it, we get iron spheres. Many of these spheres are nearly pure iron. Not enough oxygen in them to be iron oxide, you see. Less than 1-to-1 even. So we get molten, because it was spheres now, iron that are formed from the red chips when we just heat them up to about 430 centigrade, as we'll see. They react and release a lot of energy, and then we get molten iron. Folks, this is the signature for a thermitic reaction. And we nailed it. It took a long time to nail it, but we did it. We nailed it. One thing I'd like to get perfectly clear, if I can possibly, and I wish there's someone here from NIST who would listen to this. Thermite, I agree, is an incendiary, ordinary thermite, which means powders of aluminum and iron mixed together. And they burn as incendiary. So you see this molten material. This is ordinary thermite here in the photo. And you see the molten iron coming out of that. It's an incendiary. It melts things. But the ultrafine grain form is an explosive. It reacts very fast. The smaller the grains, the faster the reaction. That's been demonstrated in published papers. And we see, for example, this is from a Lawrence Livermore National Lab. Anybody here from Livermore? I welcome you. I'd like to discuss this with you. In fact, we have been in contact with Dr. Tillotson. Dr. Fair has been in contact with him. Haven't learned too much yet, but they've published papers, as we'll see. To me, this is quite exciting. In the lower right, you see the explosion of this. It's called nanothermite or superthermite. This is the ultrafine grain. Okay, now a quick quiz. Superthermite is A, incendiary, or B, explosive? B. Okay, very good. Now, actually, you can tailor nanothermite, which is interesting, so that you can make it react faster, slower, louder. It just has all these variations. You can tailor it. But it can be explosive, is what I'm trying to say here, as you see from the photo from Lawrence Livermore National Lab. I had a BBC crew came through the lab, took photos, videos, of me and I think others in the lab as we worked on these red-gray chips. And interestingly, they asked Livermore if they could show this a photo from a published paper, and Livermore declined, would not allow them to show nanothermite exploding. But it does, you see. It's very important. I have here a nail, which is rusty, and a piece of aluminum foil, such as you might find in, in buildings. There is rusty iron and there's aluminum. Does this make up thermite that will form an incendiary, for example? The answer is no. I've done experiments with stuff like this. Large chunks of rusty iron or steel combined with large chunks of aluminum do not make for a vigorous reaction as we've seen in thermite. It requires these intimate mixing of smaller particles of aluminum and iron oxide. You can actually get a small spark. I've done that too with this. Just one spark is quite typical. If you hit this hard enough, for example, you can get one spark, but not the vigorous reaction, and certainly not like nanothermite. Okay, let me move on. Here we see some, and I thank Ken Jenkins and Dr. Humenn, for doing the steadying, the stabilization. You see this photo? I'm sorry, the video of, this is the South Tower just minutes prior to its collapse. Let's see if we can look at that one more time. In the lower right-hand photo we see thermite, okay, just so you can compare the colors and so on. Now watch, if you watch here closely, this is stabilized, you know, the person holding it couldn't hold his camera that steady. But if you watch this orange, yellow, oh, see there, the cloud wisp away, the white, it looks just like aluminum oxide. So this is something I've been in discussion with NIST about too, what that can be. And I suggest that could be the product of the thermitic reaction. Okay, aluminum plus iron oxide in ultrafine, as we have observed now in this red material. What does that imply? We look at a published report. It's available April 2000, so about a year and a half roughly before 9/11. Here's what they say. Energetic nanocomposites of iron XOY, that's various ratios of iron and oxygen, and metallic aluminum. So iron oxide and metallic aluminum, elemental aluminum, these can be formed. This is called nanothermite or superthermite. The compositions are stable, safe, and can be readily ignited. I've got the equation at the bottom. That will also be on the quiz. Thank you. Okay, let's carry on. I just think it's so interesting to read these early reports. How do you characterize a nanothermite? Well, they explain. Energetic nanocomposites are a class of material that have both a fuel, aluminum in this case, and oxidizer, iron oxide in this case, component intimately mixed, and where at least one of the component phases meets the size definition, which they say is less than 100 nanometers to make the nanothermite. And that is the case for the iron oxide grains, which are just about 100 nanometers and quite uniform. Also, the aluminum that we find in these plates, the plates are about 40 nanometers thick. Here's what I was looking for, this wonderful map. This is in the paper, so you can study it. A little bit of homework on your free time. It's just, again, just so exciting. Dr. Ferrer took these maps. Isn't that, whoa, look at that, you know? So what are we looking at here? Upper left is an image through the electron microscope. You see the bright grains. How do you know they're iron and oxygen? Well, you look at the blue picture. That's for Fe. In other words, we're scanning over, looking for iron, looking for blue. The purple is aluminum. The green is oxygen. The light blue in the lower left corner is silicon, and the red is carbon. So you see where these things lie. And what we see is that we have iron oxide and aluminum, although here you can't tell real clearly whether it's aluminum oxide or not because there's so much silicon associated with the aluminum as this stuff is constructed and engineered. It wasn't until we did the MEK separation that we found the aluminum pulled apart from the silicon oxide and that we were able to nail the presence of metallic aluminum. Again, you can look in the paper. There's another SEM map there. But again, we have this intimate mixing of iron oxide and aluminum and this very tiny grains of this oxidizer. I'll just tell you, it goes back about 10 years before 9/11/2001. Certainly long after the buildings were constructed. I get that question. No, it could not have been put into the buildings when they're constructed because it had not been developed at that time. It's a new high-tech technology. And here's some of the uses. Livermore report in 2004, they go on. By introducing a fuel metal such as aluminum into the metal oxide silicon oxide matrix, energetic materials based on thermite reactions can be fabricated. I'm not making this up. This is, these national labs explaining this wonderful explosive material. Organic additives, hence the carbon observed, can cause the generation of gas upon ignition of the materials, therefore resulting in a composite material that can perform pressure volume work. Boom, right? Explosive work. Method, and they describe a method of making nanostructured energetic materials, specifically explosives. propellants, and pyrotechnics. Nanothermite. I'll let you read some more in the paper. Read the last paragraph. We have prepared fine powders, pressed pellets, cast monoliths, and thin films of the hybrid inorganic/organic energetic nanocomposite. Hence, we expect to see carbon, that's the organic portion, along with iron oxide and aluminum, just as we observe in this exotic, highly engineered red material. Okay, let me go again. Here's the carbon, just to remind you there's a lot of carbon in there. So it has the proper ingredients for nanothermite, has organic and inorganic. How does it compare with known nanothermite when ignited? Let's heat it up like they do at the national laboratories and find out. So here's what we did. It's done by Dr. Fair. The blue curve, the red fair was done by Tillotson et al. At Lawrence Livermore National Lab. The red curve then is known nanothermite, and we see a temperature. So in this differential scanning calorimeter, it's on the quiz, okay, DSC. Okay, so you heat this material, any test material, slowly. In this case, we use their conditions, 10 degrees centigrade per minute in air, and you heat it up, and in their case, the nanothermite, they made it, they know what it is, that's the red curve, goes off at just about 500 centigrade. In the case of this, and the peak there is actually quite narrow compared to regular thermite. It's also at a lower temperature. I'll show you that in a minute. You know, this is the way we can distinguish nanothermite another way from regular thermite. The red chip, from the red material from the World Trade Center dust, I can't remember. Yes, it says McKinley. This is a McKinley sample, Jeanette. And look at that, very narrow, and goes off at about 430 centigrade. A little lower in temperature. The finer the material in general, the lower the temperature at which it ignites. The narrower the peak, the more explosive, you see, the faster the energy release. The World Trade Center red-gray chip ignites at a lower temperature than ordinary thermite, and it's narrower, this is called an exotherm, than even known nanothermite from just down the road here, Lawrence Livermore Labs. Okay, now here we have a paper by Gash and so on, et al. At the Energetic Materials Center, Lawrence Livermore National Laboratory, published in this proceedings. On the left you have ordinary thermite. On the right you have nanothermite. If I can help you read the scale. The ordinary thermite goes off at about 900 centigrade, and their nanothermite goes off at just below 600. Looks like about 550 in this case, centigrade. Again, the finer the material, the lower the temperature. So that distinguishes, again, nanothermite from ordinary. Notice how much broader the ordinary thermite peak is compared with nanothermite. This is like no paint you've ever seen before. Let's review quickly. The red material will not dissolve in MEK. This is after 55 hours. There's this hard chunk left. I've got a photo of it down at the bottom. It's highly porous, high in silicon. This skeletal silicon oxide matrix remains after long soaking, whereas ordinary paint dissolves. Resistivity differs. It's attracted by a magnet, the red material. It has carbon, silicon, oxygen, iron, and elemental aluminum, but no zinc on a clean surface, no magnesium, no manganese to speak of, no titanium, no chromium. So I'd like to see a paint that has that. Of course, it might be a fairly explosive paint, you see, as we're finding out. The iron oxide is in quite uniform grains that are approximately 100 nanometers across and faceted. The aluminum is found in plate-like structures. Again, I'd like to see a paint like that, but don't bring it too close to me when it's dry, please. Further tests that characterize these red-gray chips and therefore characterize the World Trade Center dust. You see, now we can tell when we've got World Trade Center dust because it has these striking, unusual red-gray chips in it. The red layer ignites at about 430 centigrade. The DSC trace is narrow, and it produces iron oxide spheres. Let's see if that's next. Nope. Okay, coming up soon. The spheres that are produced as this stuff goes off. Again, I want to point out, as we observe, that these are uniform grains, intimately mixed, nanoscale, narrow exotherm. This is an engineered material. This does not happen just from a building collapsing. I should add, we actually looked at dust from ordinary controlled demolition, so you have then this collapse of buildings caused by explosives, but ordinary explosives like C4. We looked at the dust in some detail, Daniel Farnsworth and I, for red-gray chips. This was the demolition then of the Stardust Resort in Las Vegas. No red-gray chips at all, and we plowed through a lot of material. Same way with the Key Bank in Salt Lake City. These are discussed in the paper. These are controls, and no red-gray chips in the controls, okay? Just in the World Trade Center dust that we've seen. Okay, oh boy. You can read some of this in the paper. I'll let you do that, but this is from an April 2001 conference in San Diego, and they say in the middle here, the breadth of the work ongoing in this field of nanothermite and other related nanoenergetics is roughly 10 years old, so it goes back to about 1991. Was available by, obviously, by 2001, when this conference was held in April. At this point in time, all of the military services and some DOE and academic laboratories, and certainly overseas laboratories as well, have active R&D programs at exploiting the unique properties of nanomaterials that have potential to be used in energetic formulations for advanced explosives. These results were published in MTEC Quarterly, Department of Defense publication, I understand. And as we look at this, that's what I was just quoting from, this meeting held in April 2001. Now look, this is from the article talking about the uses of this advanced energetic material, this nanothermite, for example. At the top you see kinetic energy munitions. In the middle you see thermobaric applications for nanothermite. And at the bottom you see a very interesting application, a shaped charge. This explosive material can be formed into a shaped charge just like C4 and can cut through steel, not melt through, right? You see the difference, right? Ordinary thermite is incendiary. Nanothermite can be formed into an explosive shaped charge. They're after me, but I'm hanging in with you guys. There's the sirens in the background. But no, that's just straight out of this report. Shaped charges can be made. Now, it's not easy to make this stuff. This is again from the report making the nanoscale aluminum for these high-tech explosives. This was done at a naval facility. Incidentally, again, this material could well have been outsourced. I'm not saying it was necessarily done even in this country. That's a very interesting question, where this stuff was made and who made it and who ordered it made and who put it into the building. Those are the crucial issues. This shows what is required to put these materials together. Very high-tech process to intimately mixed ultrafine aluminum with ultrafine iron, again out of this AMTIAC report. How much material was in the dust? I want to go through this argument quickly. We report in the paper, the first paragraph is a quote from the paper, 15 small chips having a mass of 1.74 milligrams, extracted from a 1.6 sample of dust from which readily identifiable glass and concrete fragments had been removed by hand. The fraction then of red-gray chips was approximately 0.1% by weight in the separated dust. The unseparated dust is about 3 times that. A rough estimated amount of dust from the WTC destruction is estimated. I refer to work by Gregory Urich, 90,000 tons. He sent me an email actually about that. That brings us to about 27 tons of the red-gray chips in the dust. Again, this is just based on what we observe in this sample. There's a lot of material. If you just look at the red material alone, it's about 1/3 the mass of the red-gray chips, which works out then to about 9 tons of active thermitic material. A very rough estimate, as I must emphasize. Our conclusion is that we have found a very energetic, highly engineered, explosive, pyrotechnic material in the World Trade Center dust in abundance. The questions now are, who made this stuff? And why has NIST refused to even look for World Trade Center explosive residues? Also, USGS have asked them. They have not replied. Will they do so now? Now, I want to foresee questions. I don't know exactly how this material was used. I've given some hint. But I don't know. It could be, as we explain in the paper, that just the thin material survived and that thicker layers of this red material were actually used in the building. The point is there's a lot of it, and it should not be there in a commercial building occupied by humans. Details of exactly how they used this to destroy can be learned once we find out who made the stuff in multi-ton quantities. Subpoena power is needed. Again, once you find an accelerant, in these photos, thermite was found in the residues of this fire. It proves that there was arson, there was intentional destruction. That's what we have in this case. We have these identified now materials in the World Trade Center dust. The U.S. government oversaw, I think it's fair to say, someone certainly allowed the destruction of 99+% of the World Trade Center steel. That evidence was destroyed. We want to prevent this from happening to the World Trade Center dust. I found out from Jeanette and others that much of this dust was simply dumped at the Fresh Kills dump. Staten Island, isn't it? Yeah, Staten Island. Family members have sought some of this dust in vain because it does have fragments of human bone and hair and so on in vain. Now they were promised, was it the first anniversary that they...
Well, on the first anniversary they gave all the family members urns.
Urns.
They said that they were going to give them remains. I mean, it was a symbolic...
Come up here real quick, Jeanette. They can't hear you.
I just said at the first anniversary they gave the family members urns, ceremonial urns, silver urns, saying this is, you know, your loved ones. But the reality was it was beach sand. When those families opened up those urns thinking they were going to have remains or symbolic remains, they wouldn't let the families have any of the dust. And to this day they haven't let the families have any of the dust. So.
Wonder why not. I don't know. But we must not allow this dust to be destroyed. It is full of information, incriminating data, as we've shown. Now, I support strongly the New York City CAN referendum that Jeanette described earlier. The power to, by supporting this referendum, if it passes, there will be a mandate to form a new investigation with subpoena power. And I have contributed to this effort. So my concluding slide, the international 9/11 Truth movement and community is strong and growing. We can support the New York City CAN referendum. I like that. New York City can do it. They can initiate this investigation. There could be other places, like an international group of scientists, to investigate the World Trade Center dust, for example. We can point people to published papers, their DVDs. It requires of us courage, I believe, and love and truth to take action with civility. And let me just say in closing, just in case, please get your food storage. Thank you. Thank you.